We're going to start a new game project. So let's go up to the new dialog, do a new empty project. I'm going to set the layout size to 800 by 800. Make sure that you go to view and set the window to the same thing, 800 by 800. This will be a single screen game. Then on the first layer, which we are going to call background, going to add a new sprite. Go to load, go to Stu Share Game Programming Tetris and load our board. I'm going to zoom out a little bit. The origin doesn't particularly matter, but what does matter is the collision polygon. So we're going to right click on a point and add a new point. Should go halfway between that and the next point, drag it to about that corner. We'll add another point to go down here, add another point to go here, add our last point to go here. The normal four corners should already be set. Each other one should be pretty close to where we placed it. So this one should actually be 80, 0. This one's going to be 80, 720. This one will be 480, 720. 480, 0, and the rest should be fine. Then we want this to be set in the corner. To make it easier to place this, I'm going to go to View. I'm going to turn Snap to Grid and Show Grid on. We're going to set these both to 40. And with one of the peculiarities of Construct is that changing those doesn't update right away. So as you change one, toggle grid off and on, and it should work when you do that. Then I should be able to move it, and it should snap into that 40 by 40 location in the top left corner. Since we've drawn a grid on our background, we don't actually need to show it, but you can have it on if you'd like. So this object I'm going to name board. Then I'm going to lock my background layer, create a new one, and this is where I'm going to put my pieces. I'm going to create a new sprite over here on the side, and that is going to be all of the pieces I need. So I'm going to start with my red Z block, add a frame, add the S block, add a frame, L block, add a frame, J block, add a frame, T block, add a frame, open up the I block, add one last frame for the O block. Now what's important for these collision polygons is that we actually go one pixel in so that as a block is coming down, it doesn't have the corner of the block touch the corner of another one, since each of these blocks is exactly 40 by 40. So in this top corner, we're going to want this to be 1, 1. This next one is going to be 79, 1. This one here is going to be 79, 41. 119, 41, 119, 79, 41, 79, 41, 39, and 0, 39. Then we'll go to our next block and do the same thing. So it's 1, 41, and really these things don't have to be exactly exact. Since we're going to be moving our blocks multiple pixels at a time, in fact 40 at a time, since they're going to be moving a whole block. If it's approximately close to the corner and inside, then it should be good enough. 119, 39, 79, 39, 79, 79, 179. And that is our green block. Start with orange. 141, 81, 41, add a point, 81, 1, 19, 1, 119, 79, 1 and 79, 1 and 41. Go to blue, 1, 1. Second point is 39, 1. Add a new corner. 39, 41. 119, 41. 119, 79. 179. Top left corner should be 1, 1. Move to frame 4, which is purple. Our top left corner is 41, 1. Our second point is 79, 1. Add a point. 79, 41. 119, 41. 119, 79. 179. 141. 41, 41. Purple's finished. Then the easy two with only 4 points, we have 1, 1. We have 159, 1. We have 159, 39. And we have 139. Then our last one is 1, 1. 79, 1. 79, 79. And 179. We will name this guy block. And while we're here, let's go ahead and add an instance variable. We're going to name it canMove. That is going to be a Boolean, and it is going to start off as true. So whenever we create our block, it will initially be able to move. So we have canMove as true. This is so that we don't accidentally let something move after it's had a collision. Let's head over to Event Sheet 1. I'm going to start off with a global variable. I'm going to name this block size. I'm going to make this a constant, which means it won't change. And the value for this is 40. Usually when you make a constant, you put it in all caps. Hit OK. I'm going to add another variable. This is going to be my fall delay. This will be the amount of time we pause between each time it falls another square. That will be a number, and we will start that off as 1.0. I'm going to create a group for block falling. It's going to handle the falling of my blocks. And I'm going to add a sub-event. And that will be system every X seconds, and that's going to be our fall delay. I'm going to add another condition to that. When our block Boolean instance variable set can move, so if our block can move, we're going to let our block's y value, so set y, be equal to its own y value, self.y, plus our block size. So go back to layout 1, set my block up inside my grid. Don't worry about it being off-centered right now. We will reset the origin points for each sprite later. And we'll run that, and it should get our sprite moving. Now it should continue to fall straight through the bottom of the world when it gets down to the bottom. We'll implement collisions next time, but this is a decent start so far. Move this back over. I'm going to go ahead and go to my origin and set each of those values. So my origin is going to be based on the square I want it to rotate around. So I'm going to pick the square I want it to rotate around and make sure that I have that at the right spot. So that's 60, 60 here. It's going to be 60, 60 on the green one. It's going to be 60, 60 on orange, 60, 60 on blue, 60, 60 on purple. We're going to have it right here, which is actually 60, 20 on our I block. And it's going to be right in the middle, 40, 40 on the yellow block. We'll notice that it now does not match up with our grid at all. That's okay. We will just adjust for that on each of the blocks that doesn't line up. The main point is that our origin is set at a point so that when it rotates around that piece and not the corner of our object. And this seems like a good stopping point for this lesson.